Hello everyone, this is Shalini Sheetal from Shecoders NITR, and today we are going to cover the next topic in our series of Python tutorials, namely functions in Python. So what exactly is function? Let us begin with the definition of a function. A function is basically a block of code which only runs when it is called. You can pass data known as parameters into a function, and as a result, the function can return data as a result as well. We have used many built-in functions previously, for example, length of a list or the size or insert, pop, push. These are already built-in functions which are provided by Pythons. Functions can be classified hence into two categories, namely inbuilt functions or the predefined functions by Python, and the second category are user-defined functions. We shall first begin with built-in functions or the predefined functions in Python. So if we import the module built-ins and print it directly, you can see numerous multiple built-in functions which are provided by the Python interpreter. Now, what are built-ins? You must be wondering. We know normal functions, right? Why call them built-ins? So the built-ins are basically automatically loaded every time the Python interpreter begins. Like the built-ins module is automatically imported every time the Python interpreter starts. So all the built-in data type classes such as numbers, string, list, etc. are actually defined in this particular module. So since this module is imported in the current session automatically, it doesn't need to be imported explicitly. All the built-in functions used in the executable code are by default considered to be from this built-in modules. So you don't need to mention that you have imported built-in explicitly, since the Python interpreter does that implicitly. So there are multiple functions provided by the built-ins module, and if we take it as a list of the directory of built-ins, and we see that we are actually familiar with all the functions beginning from apps. We must have come across many of these or the most of these functions previously. So if we find out its index, it is 81, and print the rest of the functions. These are actually the functions which will come in most handy when we are actually coding in Python. The abs function returns the absolute value, as you can clearly see. If we provide a negative number to it, it returns its negative, ultimately giving a positive result. And the absolute value of a positive result is naturally a positive number. Absolute value of 0 is 0. So, what is all now? Now, all returns a true value whenever you provide within it a list of values or a value which are all true. None of them can be false. For example, here we have one value is false. So the all function shall return false value instead of true. If we change it to true, now it returns a true value. So all returns a true value whenever all the arguments provided inside it are evaluated to true. Now, any function serves as a OR function. If any of the values provided within the arguments are evaluated to true, then it returns a true value. It is the opposite of all, we can say. Whenever one of the values is true, it returns a true value. Here, although all are zeros and there is none which is evaluated to zero, but there is one at the end of the list. So it returns a true value just because of this one value. If we turn it into 0 instead, it will again return false. So remember, any returns true whenever one of the values is true. Now, ASCII is another function which returns the ASCII value. Every Unicode character is assigned an ASCII value, right? So for example, A gives one ASCII value and this Hindi letter can give another. These are the ASCII values assigned to any Unicode character. Now, this bin function basically returns the binary value. You don't need to calculate the binary value of a number you wish to. Explicitly, there is a ready-made function for this. You can use it and it returns the binary value directly. As you can clearly see, it works both on positive and negative decimal integers. Next, we come to the bool function. Bool function basically returns the boolean value of the argument you pass. If it is a true value, it shall evaluate to true, and if it is not, then it shall give false value. For example, we haven't provided anything, it is an empty string, so as a result, the boolean value of an empty string is false. The boolean value of none is also false, but if we provide a valid argument, for example, the name Ravi here, it evaluates to true. So bool function basically returns the boolean value of the argument you pass. So we have already seen many of these functions. We cannot actually go through each and every function. The time does not permit us to do that. So you can go over all the functions, and if you encounter any doubts, you can confront it in the group directly. We shall look through some other commonly used functions as well. For example, the callable function. The callable function checks if the argument provided to it can be called or not. So basically, it is a function or not. Functions can be called, but integers cannot be called, right? You cannot call an integer, you call a function instead. So since the print value is a function, right, we always do print and then provide the parenthesis, including expressing that this has to be called. So print is callable. Range is also callable. We provide a range, pass on arguments to it, the lower limit, the upper limit, the step value. So range is also callable. But for example, a variable name as A or B or any other variable name, we cannot call a variable. We cannot call an integer. We cannot call a string value. So as a result, this evaluates to false here. Now we have already covered list comprehension previously. So if we take this list as the character value of the integers in this range, then as a result we obtain all the capital letters. This CHR function basically returns the character value of the integer provided as the argument. So the ASCII codes from 65 to 91 are from capital A to capital Z. Similarly, for the small letters, it is from 97 to 123, and you can clearly see we obtain the small letters in this case. Actually, there are a huge number of characters available to us. If we print all the characters of integers in the range 0 to 15,000, you can see we have obtained 15,000 characters here. You can see the Hindi letters, you can see the Oriya letters, Marathi, Bengali, everything is present inside this range. So, for example, you can copy and paste any random code here and then check for its value. Sorry. Since I don't have the required software installed, it won't detect it. And actually, L we haven't yet taken. Yeah, sorry. It will take some time since it has to be loaded. There are 15,000 characters, so it will take quite a longer time than usually it takes to implement anything. So now we find out the index. It shall return as a valid value, right? So you can copy any code and find out its index value in the range. So you can also print Hindi sentences if you have the required character set with you, required codes for it. You can do that. Now, suppose we take a list here and print the values which are of length 4. Then these, as I have already said, this is known as list comprehension, and you are using multiple built-ins here. For example, len is a built-in function which is provided by Python implicitly, and there is this list comprehension. You obtain all the letters or words if they are of length 4, otherwise you obtain their actual length. And this is the this is the original list, and this is the obtained list. So there are many numerous functions. For example, if you want to obtain the copyright for present version of Python, you can use the copyright function. Credits provide you the required credits. You can look through them and have a look at it. Now, another useful function is the div mod. Now, as the name suggests, it is a combination of div as well as mod. So suppose here we find div mod 10, comma 3. Then first of all, it returns a tuple. The first one basically gives you the result of the integer division here. 10 divided by 3 gives you 3.333, but we take the integer part and it is 3 here. And the modulo 3 gives 1 because 1 is obtained as the remainder. So you get a tuple as a result, and the first argument is the integer division value and the second is the mod value. Now another useful function here is the enumerate. Now, if you want to know about any function, you don't need to look through Google doing all the hard work. You can simply type in help and the name of the function, and Python provides you with all the details. So if you don't know what enumerate is, you can simply type help enumerate and it provides you all the details. So it basically returns you an enumerate object, and you need to pass on an iterable to it. Iterable is anything which supports iteration, and the enumerate object basically yields pairs containing a count from the start, which defaults to 0 and a value yielded by the iterable argument. So as you can clearly see, we begin with 0, go through entire length, and each character of the passed on string is attached bonded to a integer value here beginning from 0, increasing the step value by 1. So if I hadn't used the list here, you would have obtained an enumerate object here instead. So that's why I turned it into a list, so you obtain the tuple pairs exactly. So next we get familiar with another function, which is the next function. So suppose you enumerate she coder's string and assign it to variable x. Now, if you call the next function on x now, then it will begin with returning each enumerated pair as a result. It traverses through each item and returns you the result. And suppose here you obtain 1 comma h next. You can clearly see here, right? The next pair is 1 comma h. So yeah, check it here. The next pair should be 2e according to that. You do that and you obtain 2e. Now, since we have already traversed through the first 3 pairs in this case, now if you print the result, the first 3 pairs shall be omitted and the remaining pairs shall be printed out. Now, the eval function basically evaluates anything you pass on as a string, but it will take as a calculation and return you the integer calculation according to it. For example, we have taken here m as zero point 0.3, c as 4.6, and x as 9. Now, if you pass on a string as m into x plus c, then it returns you an integer instead, and this is the evaluation of m into x plus c. So the eval function actually comes in quite handy. You must be familiar with this function. Now let's touch another function, which is the hash function. Namely, now the hash function basically returns the hash value of an object provided it has one. So hash values are just integers that are used to compare dictionary keys during a dictionary look in a fast way. So if you provide for help hash, then you can see it is a built-in function in the module built-ins, and it returns the hash value for the given object. Now, one important thing to keep in mind is that two objects that are equal in value must have the same hash value as well. So, but the reverse is not necessarily true. So, any two objects, strings, integers, if they are evaluating to true, then they must have the same hash values as well. So, next, since we had the binary function, we also have functions for converting into hexadecimal values and octal values as well. You can check it out. We already know about the max and min functions. They respectively provided the maximum and minimum values of the iterable passed on as argument. Now, I have already said that the CHR provides the character value of the passed on integer, and the ORD function returns an integer value for the passed on Unicode character. Next, we see the power function. The first argument is the base, and the second argument is the exponent. So 2 power 3 is 8, and 8 is returned as a result. Now, there is another function, namely reversed. Again, you explicitly need to convert it to a list if you want the result. Otherwise, you obtain an object value. Sorry, L is, yeah. So you obtain the reverse value now. As you can clearly see, L1 begins from 32. Here it ends with 32. And the round function rounds it off to the next possible value. Since we haven't provided any uh, argument here, it basically rounds off to the integer, nearest integer possible. If we provide an argument saying to round it off to one decimal place, it will round to 1.3, but we omit it. It assumes it to be 0, and as a result 1 is obtained. Similarly, 1.5 is rounded to 2 because for 5 we round it to the next possible integer. Now, to sort lists, we can use the sorted functions. To find the sum of values in list, you can use the sum function. Now, the zip function basically pairs each argument in the each element in the arguments provided. For example, here red is bonded to apple, blue to berry, green to pineapple, and yellow to mango. Now, nextly, we shall be covering concepts like map, reduce, filter, user defined, and lambda. So, first, let us begin with user defined functions. Now, user defined functions basically have three parts, namely definition, calling, and return. This is the usual syntax of a function in Python. To call a function, we use parentheses and the name of the function followed by parentheses. And in Python, a function is basically defined using the def keyword. So you need not mention the return type of the function, but you must mention def for defining a function. This is the usual syntax. You write def function name, provide the code value, and if you want the function to return something, you can return a value as well. And then if you want to execute that function, then you need to call it explicitly by using parentheses with the function name. For example, here is the add function to add two integers and it prints the result. And here we have called the add function outside of the function. As you can see, the indentation provides the scope of the function, and where the indentation changes to something else, the function ends. So this is the definition of a function. This is the return state. This is the return statement in this case. And if you want to assign the value of the return, then you can use a variable and then call it separately. So nextly, yeah. So what if you print something? Like you assign the value of this function to a, and then you print it, then it shall return you as A, because A is returned to no value here. Here, add function does not return anything. It prints the result, but it returns none value, right? Equal to null. So if you assign it to a variable and print its value, then it will turn out to be none. For example, firstly, the print statement here is executed, right? And as a result, my name is printed here. But after that, the print function returns nothing. So as a result, for the remaining print statements, we obtain all as none. So here, for example, if you want to take in arguments separately, then you can type in your name, Shalini, and As a result, this print statement is executed when hello is called and you pass on an argument. Now, this is a simple function used to swap two numbers. A, for example, A is 32 here, B is 12 here. Then you can simply write A comma B is equal to B comma A in Python, and the value shall be swapped out. Now, what if you want to provide arguments on your own? What if you don't want to take A as 32 and 12, instead you want to provide them? Then in that case, you need to pass on parameters or arguments to function. Here, within parentheses, we have taken two variables a comma b. These are known as the formal parameters, and when we pass on some value, actual value to them, in this case 44 and 33, then those are the actual parameters, and the variables present inside the function name, function definition, those are the formal parameters. So here we have passed 44 and 33, and then the values are added and we obtain the result. Similarly, for swapping the values, you can simply return b comma a, and a shall be assigned the value of b and b shall be assigned the value of a. The print function must have been working quite similar to this. Suppose we take an, yeah, function names cannot be keywords, so you cannot write simply print here. So I have added these just to differentiate, and we return the same in string in this case. And if we print call that function and pass on a string, then we obtain the same string as a result. Similarly, you can use the area function to calculate the area of rectangle, circle, triangle, anything you want, and you can build a calculator using that. You can express here. I have taken a calculator function and we check for each operand and return the value according to that. And if we don't obtain a valid operator, then we return an error statement as well. So here, let me show you the working. We first take the first number and then we mention the operand operator, and then we write the second number. So as a result, we obtain 20 minus 65 is minus 45. So this function basically checks for the operator you provided, which we have passed on separately in this statement, and then provides you with the result. I hope it is clear. Similarly, you could have taken an expression and then use the split function to find out the arguments separately. You could have also used the eval function to directly evaluate the strings. Now, let us look at some commonly used functions, interesting functions to get you acquainted with. For example, the factorial function, right? You can return or use the factorial function to return the factorial. First, you take fact as 1 and then you evaluate it up till the number required and then return the final fact. What functions actually do is that they make your code very modular, so it is easier to debug and easier to locate an error if you want to. You don't need to repeat your code. For example, if you want to find out the sum of numerous lists, then you can simply have one sum function and call that for all the lists instead of evaluating the sum of each list again and again separately. So that is what functions do for you. Firstly, they make your code modular, easier to debug. Secondly, they avoid repetitive code. So you don't have to work more hard. You can simply write a function and call it numerous times instead of repeating the same code again and again. Similarly, this is the prime function to check if a number is prime or not, and if it is not, it returns false, and if it is prime, then it returns true. So this is the main function used to check if a number is prime or not. We call the main function, enter the required number, and check if it is prime or not. Now, for example, if you don't want to write any code within a function, then you don't. Then you must mention that this function has a scope, write something within it to indicate that this is a function, right? So you can simply use the pass keyword here, and in this function a and b, they do nothing. The execution begins and encounters pass, and the function execution breaks. comes out of the function after that. So nextly, for example, we take another list, and if we check it's whether it is callable or not, a and b here are functions, right? So they are callable. So for 1 and 2, for a and b, we obtain that those are functions, and for the rest, we do not find that they are callable. If we check the type of a separately, then it turns out to be a function. Now, this prime function comes in handy when we want to check if a number is prime or not in a particular range. You can simply iterate through each of the values and then call that prime function to check if they are prime or not. Now, you can also assign some default parameters to the list. For example, if we don't pass any value explicitly to this function, then by default the value of c shall be 10. So, in order to avoid the program crashing or something, it is actually very a wise option to assign a default value to the parameters. Nextly, we see that multiple arguments can be passed to a function. You can use the asterisk symbol to indicate that it is an iterable, and as a result, you can pass on multiple values and it treats them as one single argument consisting of multiple values, and it returns the sum. As you can clearly see, args basically works like a list here. We indicate that it is an iterable, and hence we can iterate through it and return its sum as a result. As you can clearly see, it returns the same result as the inbuilt sum function provided by Python. Now, another thing is that we can also provide key value pairs instead of providing simple arguments in the list. Instead, you need to use double asterisks now, and for just like we used to do in dictionaries, you can write quarks.items. This is the usual convention for naming. You can take anything you wish to, and if we print its values, you will see that you obtain the dictionary as a result, which serves the same as zip function as well. If you compare these values, they are same. Hello for you, hello for you. So instead of passing key value pairs, you could have directly used the zip function. This is what the zip function does. Now, another important concept which is only provided by Python is the lambda function. If you have really small functions, one line codes, you don't need to write def function, use return values and assign code to them. You don't need to do all those stuff. Lambda functions make your work very easier. If you want to write a one line function, you can simply assign a variable to it, just like you do for an integer or a string function, string value, and then the part before the colon are the arguments passed, and the code you want to execute is for the statement part. So always the syntax is the variable you want to assign is equal to lambda keyword, and then the arguments come, and after the colon you write your code there. For example, add here is the variable name, lambda is the keyword, x is the argument passed, and you return x plus 100. So if you call add 4, then as a result you obtain 4 plus 100, which is 104. Similarly, the arguments passed here are x, y, and z, and as a result, you return their multiplication, their product. So if you call mul with 345, their product is returned as 60. You can also use if else statements within lambda. For example, here we have passed on x as argument, and we return that the number is even if its modulo 2 evaluates to 0, otherwise the string that the number is odd is returned as result. So this one line can be used to check if a number is even or not. Similarly, you can use list comprehension. So list comprehension also makes use of for loops. So lambda functions really come in handy. Similarly, in order to swap two functions, you can simply write lambda x comma y colon y comma x, and the variables are swapped as a result. So if you have a really short function, then it is really better to use lambda. Now, recursion is a concept which has vast use in data structures and algorithms, and they really are very important if you want to be a good programmer. So, we cannot cover that elaborately here, but I shall brief you about it. So, recursion happens when a function basically calls itself with a smaller argument. For example, in this function, we call the factorial function again with a smaller argument with 1 less than it, and it calls itself again and again and again until num becomes 0. And once it becomes 0, then 1 is returned. And then we trace back again and again and again to return the final result. So lambda functions can also be used in recursion. Here, instead of returning the direct value, we have called the lambda function again with a smaller argument. So whenever you have a case of iteration, you can also use recursion instead. Whichever is more familiar to you, go for it. Now let's cover the concept of scope. So here, as you can clearly see, we have taken a function hey and declared a variable x inside that. Now, if you want to access that x and outside of that function, then it will say that x is not defined. If you want to access x, then you have to declare it outside of all functions, and only then can you print its value. Now, if you take another x inside the function and access it inside that function, then it will take the local x. It will take x as 6 here. And since outside no x with 6 is present, x is defined as 5, the outer print statement will print the value of x as 5. If you want to explicitly mention the type of any variable, you can declare it as global, and this x shall be accessible by any function all throughout the program. But instead, if you would have used global here, it would have worked just as the same way, and the print statement both inside the function and outside print the same value as a result. So nextly, let us cover the concept of closures in Python. So first of all, as you can clearly see, we have a function teacher here and another function inside it, which is student. So this is the case of nested functions where one function is present inside another. So closures make use of nested functions as well. If you call teacher here, first of all, this statement is executed, and as a result, student is returned as well. So if you want to call the student function as well, then you need to add a set of parentheses within it. And if you call that, then this statement is executed, and hi am student function is printed as a result. So here there are some conditions which can be used to define a closure. As I've already said, that we must have a nested function, which is basically a function inside another function. Second condition is that the nested function must refer to a value defined in the enclosing function. So the function which is present inside another must be referring to a value which is present in the outer function. And lastly, the enclosing function must return the nested function. For example, in this case, it shall become clearer with an example. The argument message is passed to the outer function, right? And this inner function accesses the variable present in the outer function, which is the variable namely message, satisfying the second condition as well. And lastly, the outer function returns the inner function also. So this is the case of a closure. Now, if you call the outer function and then you call the try to call the inner function as well, then surprisingly you obtained hello, right? The print message function was called with the string hello, and the return function was actually bound to the name another. So on calling another right here, the message was still remembered although we had already finished executing the print message function. So this technique by which some data gets attached to the code is called closure in Python. This value in the enclosing scope is remembered even when the variable is out of scope in this case, or the function itself is removed from the current namespace. So this is what closures are. Similar to that, decorators also come in handy. They use the concept of closures as well. For example, we have outer function decorate and another function inner, and decorate returns inner as a result. But as you can clearly see, we can access the passed on argument to the outer function, which is func in this case. So for using decorators, you can simply write at the rate decorate and then mention the required function. And automatically Python understands, and this function is passed on as the argument to the function decorate, and these arguments, namely a and b, are taken as the arguments for the inner function. So if you want this particular decorate function to be used in numerous functions, then you can simply write one decorate code and just write one simple line at the rate decorate, and all the functions shall be executed in the similar way. As you can clearly see here, we have used the same decorate function for multiple codes. Lastly, we shall be covering three important concepts of map, reduce, and filter. So, first of all, I have imported the random module to be accessing just random integers to make up a list for it. And then we use another function, take an empty list, and for each variable in list, we append the multiplied value of var here, right? You pass on var here and it returns a into 5. So this is a list consisting of all the numbers multiplied by 5 in the list L. Now the same thing could have done by using just one keyword. Instead of this entire code, you could have simply used map mul L, and this function binds the function of multiplication to each element in list. It traverses each element of the list and executes the function of mul on each of them. And since we have again converted into a list, we obtain the final list as a result. So the list function basically binds each value in the iterable to the function we have provided as argument. For example, we have taken here the string values of all the integers from 1 to 5. Now if we map it to the function of int, to the value of int, we obtain as a result a list of only integers. Nextly, the function of reduce is also important, but you need to import reduce explicitly. And what this statement does is that it passes the list as argument to the add function and returns the sum of all the integers present here. It is reduced to one single value. Reduce, or its name clearly implies its meaning. So all the values are added up and one single sum is obtained as a result. Using the sum function as well, we obtain the same result. Now filter is basically used to filter out certain values from a list satisfying certain criteria. So in this case, if we use the filter function on this particular list and check if the element is divisible by 2 or not, then it filters out the values, and whichever elements satisfy the criteria returned true in the filter function are returned as result. So only the even values from this list are filtered out and we obtain the required answer. So this is all for today. I hope I have covered most of the concepts. If not, you can ping me on WhatsApp and I shall be clearing your doubts as well. Thank you. Have a great day ahead.